It has asked, aeroplane is tracking away from an NDB station, maintaining a track of 120 degrees, 15 degrees starboard drift. What will be the relative bearing of your aircraft? So, very important point is you're tracking away from an NDB station and on a track of 120 degrees and 15 degrees starboard drift. So, these three are the keywords. So now relative bearing formula you all know. Relative bearing is magnetic bearing to the station minus magnetic heading. Okay. Now the track that you are tracking away from NDB is 120 degrees. 120 degrees. And the drift is what? The drift is 15 degree starboard. 15 degree starboard. Okay. Now if you have a starboard drift, in that case, the heading of your aircraft will be less than the track of your aircraft. So when you have a 15-degree starboard drift and track is 120, so heading will be equal to 105 degrees. Heading will be equal to 105 degrees. So let's substitute the values now. But the formula says you need magnetic bearing to the station. What is magnetic bearing to the station? If QDR is 120, QDM, which is magnetic bearing to the station, will be reciprocal 300. So substituting the values, you will get 300 minus 105, which is 195 degree. So relative bearing will be 19 uh, 300, so 195 degree. So it should be option C. There must be a printing error. So this should be 195. Okay. So I will just double check 300. It should be 1905. That is a printing error. Next, this is your NDB station. You're tracking away on a track of 120 degrees. The magnetic heading of your aircraft is 105 degree. QDM, track towards the station, is what? 300 degrees. So now what will be the relative bearing? Relative bearing will start from your magnetic heading, this, which is 15 degree, plus this entire thing, which is 180 degree. So total will be 195 degrees the relative bearing. So remember this. This is how you do it. Next, ADF bearings by an aeroplane by daytime within the published protection range should be accurate to within a maximum error of how many degrees? So it should be maximum of plus minus 5 degrees. So this is what I have explained before, that NDB stations, every NDB station will have a published protection range or designated operational coverage, right? So if you go beyond that range, maximum range from that NDB, you will have to switch your frequency from the previous NDB station to the next NDB station. Okay. If you don't do that, there will be station interference. There will be station interference. That means the aircraft will receive signals from both NDBs simultaneously. There will be confusion and hence bearing errors. So if this is your NDB station, this is your NDB2 station, Is the published protection range, let's say. Okay. So when you are traveling from one NDB station, another NDB station, better to better to switch your frequencies from this to the next station, from the previous one to the next station. Okay, to avoid confusion, to avoid interference between two different stations. And that is why, to prevent this from happening, the stations are separated by some distance from each other. Okay, so that there is no interference. They should not be very close to each other, near each other. There should be sufficient distance between the two NDB stations. We call that published protection range or designated operational coverage. So that is the thing. And during daytime, the maximum error possible or the maximum error permissible correction is plus minus 5 dB. So let's go to question 13 now. Which of the following ICAO allotted frequency is for ADF? So ADF works in the frequency band of low frequency and medium frequency. So 960 to 160 kilohertz, if I'm not wrong. So it is 1750. Kilohertz. So accordingly, the answer will be 1750. So it should be option A, 1750 kilohertz. Okay, just let me check. So it is between the range of 190 and 17. So 190 and 1750. Correction. So 190 and 1750 kilohertz. So correct option will be option A. Next, question 14. In order to obtain an ADF bearing, the signal must be received by both the sense and loop aerials. Sense aerial must be tuned separately. Mode selector should be switched to loop. BFO switch must be selected to on. So correct option is option A. So what happens is your NDB transmits, I will write it here. I have explained this in the previous videos also. Your NDB transmits radio signals all directions, or we can call it omnidirection, right? And what happens, the direction sensing aerials that is fitted on your aircraft will receive these signals and determine the direction from which these signals are coming. And in so doing, it will be able to tell you the relative bearing of the NDB station. So the ADF receivers will determine the relative bearing of the NDB from the aircraft. Now, for the system to produce accurate bearing information, it is important that all signals travel in straight lines. Another very important point. Okay, so I have explained this in the coastal refraction night effect. So all signals must travel in straight lines. Now the ADF receivers on your aircraft, the aerials on your aircraft, there are two. One is your loop aerial. The second one is a sense aerial. Okay. Now let's talk about loop aerial first. Now whenever your loop area, let's say this is your loop, This is your loop aerial. Okay. Whenever the NDB signal uh, reaches this loop aerial at any angle which is not perpendicular to the loop aerial. So perpendicular angle would have been this, a signal coming from behind or from the front of aircraft. Okay, that will be the perpendicular angle. But if this is not the case and any signal is coming from an angle which is other than this 90-degree angle, that means from here or somewhere here, like this. So if any signal, I'm writing it here, signal coming at any angle other than 90-degree, there will be voltage difference produced in the loop aerial. Okay, this is one important point. Next point, if the signal is coming, if the signal is coming at 90-degree angle, if the signal is coming at 90-degree angle, so I'm writing it here, perpendicular to the loop aerial, voltage difference won't be produced. Voltage difference will not be produced. Okay, remember this. And when the signal comes at 90-degree direction like this, there are there are two possible directions available to us. Two possible directions available to us, which means the signal may be coming from this direction or the signal may be coming from this direction. This is called 180 degree. This is called 180 degree ambiguity. That means we do not have clarity whether the signal is coming from one direction or the other. And to resolve this 180 degree ambiguity, we have another aerial called sense aerial. We have another aerial called sense aerial. Now the loop aerial doesn't give us a definite direction from where the NDB signal is originating from. So to resolve that, we take help of sense aerial. Now what sense aerial does is, a sense aerial will superimpose voltage of constant strength, okay, over the varying voltage produced by the loop aerial. This process eliminates one of the two possible directions to give unambiguous. This was ambiguous, meaning no clarity. Unambiguous means a definite answer, to give an unambiguous indication of the direction from where the signal is coming. Okay, so this is the principle of operation of your uh, NDB and ADA. Okay, so that's why we need both the aerials. We need loop aerial as well as sense aerial to determine our relative bearing or ADA bearing. So let's go to next question, question 15. Factors liable to affect most NDB ADA system performance and reliability include. So there are many errors of NDB which can affect it. So let's check the first option, static interference. Yes, so static interference is one error. What is that? When the signals collide with ice particles, water droplets in the atmosphere, there will be static interference. There will be noise that you will hear. Okay, so that is static interference. Station interference, you all know, I have explained it before many times that there should be a minimum distance separation between the two NDB stations so that the signal of one NDB station doesn't interfere with the signal of the other NDB station. And third error is latitude error. So that error is wrong. We don't have latitude error in case of NDB, but we have these two errors that is correct. Static and station we have, we don't have latitude. So option A will be eliminated. Option B says height error, station interference, mountain effect. So station interference, yes. Mountain effect also yes, because if there are mountains around the NDB station, the signals will collide with that and there will be no surface wave propagation, and that's why we have bearing errors. But height error is wrong, so option B will be also wrong. Option B will be also wrong. Okay. Next, coastal refraction, yes. Mountain effect, yes. And this is aeroplane slip, so this will be wrong. Delta says static interference, night effect, absence of failure warning system. So the most appropriate option here will be to select option delta. We have static interference, we have night effect when the D layer disappears, and that's why we have sky waves interfering with surface waves. And we also don't have any warning system in case of NDB ADF to warn us that we are receiving bearing error or an erroneous signal. Okay, so that is one another drawback. So option delta is the only option which satisfies everything. Now let's go to question 16. Which one of the following disturbances is most likely to cause the greatest inaccuracy in ADF bearings? Coastal effect, quadrantal error, precipitation interference, thunderstorm activity. So the correct option is local thunderstorm activity. Now the thunderstorm, as you all know, is a very dangerous phenomenon as far as flying is concerned. And these thunderstorms will produce great electrical conductivity around the clouds. And due to this, what will happen? The ADF in your aircraft, instead of pointing to the NDB station, it will point towards it will point towards the thunderstorm cloud. So chances are pilot, instead of flying to to his NDB station, he will be flying towards the thunderstorm cloud. Okay, so that is the all these errors are very important, but the greatest error will be produced by local thunderstorm activity because of the electrical conduction happening around the thunderstorm cloud and the relative bearing indicator pointing towards the thunderstorm cloud instead of pointing towards the station. Okay, so that will produce a very grave navigation error. So that is another thing. So let's go to next question, question 17. The BFO selector, beat frequency oscillator on ADF receiver is used for what purpose? Now our ADF receivers work in the frequency band of low frequency and low frequency and medium frequency, work in the frequency band of low frequency and medium frequency. Now to identify any kind of station, NDB, VOR, DME, there are Morse code given. Morse codes given for every NDB station, VOR station, DME station. But in case of NDB, the frequency at which these NDB stations operate, on that frequency you will not be able to hear the Morse code identifier. And if you are not able to hear that Morse code identifier because it is beyond the normal human hearing range, so you will need some other external help in order to hear that Morse code, and that help is provided by beat frequency oscillator. So what it does is, on the main NDB signal that is received at your aircraft receiver, it superimposes an audio signal. Modulation happens. The main signal is modified and an audio signal is superimposed on it so that the pilot gets to hear or is able to hear the Morse code identifier. Okay, so the job of beat frequency oscillator is to do that, to enable the pilot to hear the Morse code. So accordingly, the correct answer will be to hear the ident of some NDB stations radiating on a continuous wave signal. Okay, let's go to the next question. An NDB transmits a signal pattern in the horizontal plane, which is what? A signal pattern in the horizontal plane, which is omnidirectional. So like I have explained so many times before, an NDB station transmits signals in all directions, omnidirection. And the receivers on your aircraft, the aerials on your aircraft will determine the direction from where the signal is coming from. So the answer will be A, omnidirectional. Next, question 19. If a failed RMI, the RMI, that is radio magnetic indicator, has failed and is stuck on 090 degrees, that is your magnetic heading, and the ADF pointer indicates 225 degrees, what is the relative bearing to the station will be? So now relative bearing is equal to magnetic bearing to the station minus magnetic heading. So right now magnetic bearing to the station is indicated by this ADF pointer. So if I have to draw this, so if I have to draw the RMI indicator, what will it look like? It will have a magnetic heading information on it. So this is your RMI. On the top of it, you will hear, you will see, correction, magnetic heading. Okay, over here. Then there are two needles, one for VOR and another for ADM. Okay, so one will point towards the VOR station. It will give the magnetic bearing to the VOR station. I am coloring it. Okay, so one is for head of the needle is QDM to the VOR. Tail of that same needle will be QDR from VOR. The head of this needle will be QDM towards the NDB station. The tail of this needle will show you QDR or track away from the NDB station. Now in this case, we have a failed RMI. We have a failed RMI. That means this radiomagnetic indicator, whatever indications it is showing, uh, as far as magnetic heading is concerned, will be wrong. Okay, so it is stuck on 09 or 0 degree. So airplane may be flying on some other magnetic heading, but since this RMI indication has failed, the magnetic heading given by it will also be wrong. Opposed to that, the indications given by this QDM and QDR will still be the same. They will be the correct ones. That won't get affected. So, uh, what will be the relative bearing of your aircraft? For relative bearing, you should know a correct magnetic heading. The 225 is correct, which is your QDM towards that station, NDB station. Okay, but without a correct magnetic heading, you won't be able to find the relative bearing. So correct option will be impossible to read due to the RMI failure, right? So next, question 20. What happens in the ADF receiver when the BFO position is selected? Now I explained. Beat frequency oscillator, the purpose of it is to superimpose an audible tone on the main carrier wave or signal so that you are able to hear the Morse code identifier. Okay, so that is the job. So what happens? The BFO circuit is activated. The BFO circuit imposes a tone on the carrier wave to make NDB ident audible. That is the correct one. The BFO is activated and the receiver accepts only A1A signals. Wrong. The BFO circuit oscillates at an increased frequency in order to allow identification of A2A NDB. So that is also wrong. So the correct option is option Bravo. So that is the correct option. The beat frequency oscillator will superimpose, meaning it will put an extra tone, audible tone on the main wave so that you get to hear the Morse code signal or identifier, the identification of that station. So with this question, we have come to the end of this lecture. I hope you have understood all the questions that we have done today, all the 10 questions, the explanation, the concept, and how to solve them.